Hi, I'm Ken Rule, Senior Applications Engineer for Expand Machinery. Welcome to our first edition of Expand Machinery's Tip of the Month. I've had several inquiries lately about polar interpolation, also known as G12.1. On a lathe with live tool capability, G12.1 is a great way to create a virtual y-axis using a live end mill to do side cutting on the face of the part. Most softwares will create a polar cutting path, but if you don't have software with this capability, I'll show you a quick, simple way to program polar using a 3-axis mill program. I use polar interpolation G12.1 even if I have a y-axis on the lathe. When you use G12.1, your feature will be perfectly concentric with the part. You can activate cutter comp to adjust the size of the feature. So, let's get started. We're going to start with a 1-inch piece of material and do a simple hex on it. I'm going to use a simple 3-axis mill post to go around this piece. It's going to look something like this. To create the hex, 1/4 inch deep. So when we post it out, this is what it's going to look like. And as you can see from this point right here, which is the XY position where we're going to drop into the work at Z minus 0.25, and then we're going to do our tool path to take the end mill around the hex. So everything before this is considered mill stuff that's going to run on a 3-axis mill, and we're not running on a 3-axis mill, so we'll get rid of it. Also, the H03 has no meaning to a lathe, and neither does the G43. So we'll get rid of that also. And if we come down here, the M8's probably going to be taken care of in our tool format to begin the tool. The D23 is also not necessary because the G41 is going to go to the tool nose data, and it's going to pick up the radius of the tool and the tool nose that we're going to be using. Now, that is, if we look at the tool nose here, number 9 is the center of the radius. Normally you would use a 3 for turning, OD turning, a 2 for ID boring, and if we're going to use cutter comp on an end mill while we're milling on a lathe, we'll use number 9. So that's going to be put into our tool offset data and is not going to be part of the program. However, we do need a G17 plane, which is the XY plane. A lathe will default to G18, so we definitely need to tell it this, but we cannot tell it to go to G17 inside of the G12.1 information. So we're going to get rid of it here, and we're going to place it up before we go into the G12.1. So at this point, we have a tool path that's basically going to go over our drop-in point. Then it's going to drop into minus 0.25 at a given feed rate. It's going to activate the cutter comp according to what tool our end mill is in. Then it's going to run around the hex down to your G0Z.1, where it's going to come out of the hex after turning off the cutter comp. So everything past that point, we really don't need. So in order to create this tool path as a G.1, we're going to be creating a virtual y-axis by using the c-axis. So we're simply going to come up here and we're going to do a find and replace all the y's with a c. So then we're going to go down. We're going to do that to all of these guys on here. So that, see, we'll come back up to here and catch this one. All right. There. Okay. So all the C's, all the Y's have now been changed to a C. There's still technically a Y value, but the machine in G12.1 needs to see a C. So we're going to go G12.1 at the beginning of this toolpath, remembering that we're going to change the plane to G17 before we do the G12.1. At the end of this, we're going to do a G13.1 to end the polar. So for all intents and purposes, we're done with the polar at this point. What I'm going to do is just add a couple of moves to get up to the part. If we do a G0, we can do like an X1.6 to get the tool close to the part in X, and then we can bring it down to a Z.1, which means this Z.1 is a little bit redundant, so we'll just get rid of it. Now at this point, the machine without polar will come down to an X1.6 and drop down to 100 thousandths over the work. Then in G12.1, it will position over the drop point and then drop in Z minus a quarter inch. Now, on this, you may, if your machine has a y-axis, you may want to put in a Y0 because that's where it's you're going to want the tool in order to do a G12.1. Now that said, like I said at the opening, I use G12.1 whether or not I have a y-axis, because it will put that hex perfectly concentric on the part. And you can adjust the hex size by using your cutter comp in G41, whatever tool you're using to do this, remembering to make the tool nose 0.9. So that about does it. It's really not that hard. Anybody with a post-processor for a 3-axis mill can output this code and then go through the changes I just went through in order to do a G12.1. So enjoy, guys, and thanks for listening to our first installment of Expand Machinery's Tip of the Month. Catch you next month.